let's take a look at polynomial functions 3.3. So, the first problems are just asking us to talk about the different forms of linear and quadratic and tell us what that kind of gives about it. So, if we're looking at linear, the standard form, ax plus by equals c, what that's really helpful for is finding the x and the y-intercepts. And if you've got a story problem, it connects, the two pieces. Say like you're deciding you want to buy a certain amount of, flowers and a certain amount of Pokemon trading cards, and you only have so much to spend. You can figure out how many of each one you could buy. That's another way that's helpful. Okay, slope-intercept form is really great for graphing because it gives us the slope and the y-intercept. Okay? So it gives us the slope and the y-intercept. Now the point-slope form is helpful because it gives us a point and a slope. The slope is m, the point is this x1 and this y1. So it gives us a point on the graph and the slope. Now for quadratic, the factored form gives us those x-intercepts, also known as roots and zeros. The vertex form is great. It tells us where the vertex is. Okay, that h and that k. The standard form is helpful. The a gives us an idea of where it's going, what direction, up or down. The linear term kind of helps us understand the constant. That's the y-intercept. So it's really easy to find the y-intercept. And it gives us kind of some idea. And we can use a formula to find the vertex, but just looking at it, it doesn't really give us a whole lot of information. Okay, there's some ideas. Now, quite a few of these are wanting us to talk about their end behavior. Now, if you don't know how to graph these, I don't want you guys to get hung up on not being able to graph. So go to desmos.com, type in the graph, and use that to help you graph, because we're not focusing so much on the graph, we're focusing more on what we know about it. Okay? So, if we're looking at this graph, let's make us a y-axis and an x-axis. Now remember, this is the factored form, so it gives us the factors, the x-intercepts. Okay, so it's like we're making the f of x 0, and we can solve for x, which will tell us the x-intercepts. So we split them up. So we get 0 equals x minus 3. So we'd add 3 to both sides. Oops. To get 3 equals x. So positive 3, that's one x-intercept. Then I'd set the other one equal to 0. Get negative 4 equals x. So negative 4 is my other. So what do I know about it? I know my zeros are negative 4 and 3. Okay? So from that we can then find the vertex, right? So we count 1, 2, 3, 4, 5, 6, 7. So half of 7 is 3.5. So if I move 3.5 away, 1, 2, 3.5, I know that this line where x is negative a half, my vertex is going to be on that line. Okay, so I could plug in negative 1.5 and we could figure out what my vertex is going to be. So we'd go, f of x equals, I guess x is negative 1.5. Negative 1.5 minus 3 times negative 1.5 plus 4. So that would be negative 4.5. That would be positive 2.5. Multiply those together, and we would get our number, which is negative 11.25. So negative 11.25, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, somewhere about right there-ish. Okay? that is going to be our vertex. So we know where our vertex is. It's at negative, oh crap, I said negative 1.5, it should have been negative 0.5, huh? Dang it. Hate when I make a mistake, but it happens. Pay attention to yourselves, guys. Negative 0.5, which changes everything, right? Apologize for the mistake. You have my permission to get mad at me. But at least I figured it out, right? Better than going the whole time and not realizing it. So let's try that again. So that would be negative 3.5. That would be positive 3.5. So 3.5 and negative 3.5 make 12.25. So basically the same thing. So negative 0.5, negative 12.25, right? Yeah. That's our vertex. And because of the shape of it, we should also know that that's a minimum, right? That's as low as it's going to go. Okay. You could also talk about when it's decreasing, when it's increasing, positive, negative, stuff like that. But we want to focus more on the end behavior. So remember, as x approaches negative infinity means as we go to the left, f of x goes, where does ours go? Up, down, or approaching a number? Well, as I keep looking to the left, my graph keeps going up. That's positive infinity. So we write positive infinity. You could write up, but get in the habit of writing positive infinity. If you need to, write them both to remind you. Now let's look at the other one. As x approaches infinity, so as we go to the right, as we look at the right, f of x is going where? Up, down, or a number? Well, it's going up, so we call that infinity. Okay? Alright, let's take a look at another equation. Negative x squared minus 1. Now this one's in standard form, so it's harder to figure out. Okay. Here's a y-axis, x-axis. Okay. Well, if you don't know how to do it, you can always make a table of values. Okay? We can always make a table of values. And start with like maybe negative 2, negative 1, 0, 1, 2. See where that gets us going. So, negative x squared minus 1. So, negative 2 squared minus 1. Negative 2 squared is a positive 4. Negative 4 minus 1 gives us negative 5. Okay, if we did it with a negative 1. Negative 1 squared is 1. So we keep that negative because there's a negative outside of the parentheses. Keep that negative, we get negative 2. If we put 0 in, 0 for x squared would just be 0. It would be minus 1, right? What if we did positive 1? 1 squared minus 1. 1 squared is 1. Keep the negative outside. We get negative 2 again. So we should be able to see the pattern. If we did it with a positive 2 squared is 4. Negative 4 minus 1, negative 5. So we can see where our vertex is. Okay, so at 0, negative 1 is our vertex. At negative 1, negative 2, positive 1, negative 2, positive 2, negative 5. Okay, we can see how our graph looks. So at our vertex, we've got a maximum, and you could write that. Okay, if we don't have any x-intercepts, we have a y-intercept. Okay, at 0, negative 1. Okay, we've got the maximum. We can say increasing, decreasing. It's always negative, But let's think again, end behavior. So as x approaches negative infinity, as x goes to the left, as we look to the left of our graph, is our graph going up, down, or where's it going? Where's y going? Well, it's going down. We call that negative infinity. Okay, when it goes down. As x approaches infinity, as we go to the right, what's happening to y? It's going down again. Call that negative infinity. And there we go. Okay, there's a couple others, do those ones. But let's take a look at these. So, determine the function type and state the end behavior. So now, they're not necessarily giving you a graph. You can use a graph, but we should be able to look at least a few things and understanding the basic shape. Look at the quadratics. Okay, those were both quadratics. Notice both of them went up or both of them went down, because you either have a U shape like that or a U shape like that. So for 11, it's a quadratic. Okay, it's positive. Remember, positive quadratics always look like that. So what's its end behavior? Well, as x approaches negative infinity, as x goes left, f of x approaches positive infinity, goes up. As we go left, we go up. As x approaches positive infinity, as we go to the right, what happens to our y values, our f of x values? They're also going up. Okay? Whereas 14, they're going the opposite direction. Okay, now 13 is a cubic. These ones are more difficult to deal with. Cubics normally look something like this. But because it's got that negative, it's going to flip this down and this up and look more like that. Okay? So, as we go to the left, we're going to go up. So write it like this. I'm running out of space, so you guys just write it that way. So as it goes to the left, we're going up. And as we go to the right, we're going down. Okay? Now 12, you should notice it's an exponential equation. Okay? The way we set up exponential equations is that they have that same basic shape. Okay? There's no negatives, there's nothing that would make it look different than this. Okay? Yes, we're multiplying by 4, that just means it climbs up quicker. So as we go to the left, we're approaching 0, right? It's approaching that x-axis. But as we're going to the right, it's going to go up to that positive infinity. Okay? Now, on 15, 16, 17, 18, and 19, if you have to, get all the graphs on Desmos side by side and take a look at them. Decide which one has the greatest value to x equals 1,000. Put in 1,000 for x, or graph them and go to your x value of 1,000 and see what they're doing. Which one is always increasing, which one is always decreasing. Okay? Relative max, min. Look at those. I think that's stuff that you guys can do. But graph it on a graphing calculator or that Desmos website. That's a great graphing calculator. Take a look at the graphs. That's the focus, is looking at those graphs to help you out. Okay, the last one's kind of review of just solving for x. So just a reminder. So if you have one like 20, there's no other x's, so you would just add 16, giving you x squared equals 16. Take the square root, and we get x equals the positive and the negative square root of 16, which is 4. If you're looking at one like 24, take each one of these separately, set them equal to 0. Okay? Solve them separately like that. These other ones, factor, factor. You can complete the square or subtract 12 from both sides and either factor or use the quadratic formula. Remember this, opposite of e plus or minus square root of b squared minus 4 times a times c over 2a. You can do that on these ones as well. Okay, 25, you've got an x, and you also need to simplify that one. Okay, if you simplify that one out using Buck's method, 9 x squared, factors of 9 that add up to negative 6, got to be negative 3x and negative 3x. Pull out an x. So 9 is really negative 3 times negative 3. Pull out a negative 3. Pull out an x. Pull out a negative 3. So you get x minus 3 times x minus 3. Or, you should realize that that's x times x minus 3 squared. And solve it. So x equals 0, because you split that one up. And you get x minus 3 squared equals 0. Take the square root of both sides. Square root of 0 is 0. Add 3. We get x equals 3. Okay. Using the quadratic works as well. feel free to use that. Now, I'll do 2 of these to remind us how to multiply. Okay, when we're multiplying, let's take a look at 27. Okay, just think of it like this. Take the first term, multiply the second term. Okay, so it would be 3x times 3x, which is 9x squared. 3x times 5 plus 15x, negative 5 times 3x, negative 15x, negative 5 times 5, negative 25. Positive 15x, negative 15x, they cancel out. We're left with 9x squared minus 25. Okay, that's one way to do it. That's the FOIL method. You can also do the box method. The only difference is this would be 3x minus 5, 3x plus 5, then multiply. 3x times 3x is going to give us 9x squared. 3x times negative 5, negative 15x. 3x times 5, right? We're just multiplying the boxes, just kind of doing the opposite of the factoring. 3x times 5 is 15x, then 5 times negative 5, negative 25. Those two cancel out, you're left with 9x squared minus 25. Okay? Okay, there's a third way you can do it. You can treat these just like numbers when you multiply. So 3x minus 5 times 3x plus 5. When we multiply. 5 times negative 5 is negative 25. 5 times 3x is 15x. Then, when we go to the next term, we have a plus 0 here. 3x times negative 5, negative 15x. 3x times 3x, 9x squared. Then we just add those. Negative 25 plus 0 is negative 25. Positive 15 plus a negative 15x, that's 0x. 9x squared. So get rid of that, we get 9x squared minus 25. So you can use any one of those to help you do it. Okay? Any one of those methods. So let's do number 28 as well. FOIL, x times x is x squared. X times negative 9, negative 9x. Negative 9 times x, negative 9x. Negative 9 times negative 9, positive 81. Combine those, x squared minus 18x plus 81. Okay, if you're using the multiplication method, x minus 9, x minus 9. Negative 9 times negative 9, positive 81. Negative 9 times x, negative 9x. Okay, plus 0. X times negative 9, negative 9x. X times x, x squared. Add them, we get 81. Negative 18x and x squared. Same thing. Or we could do the box method. X and negative 9, x and negative 9, it's like minus 9. X times x will give us x squared. X times negative 9, negative 9x. X times negative 9, negative 9x. Negative 9 times negative 9, positive 81. Then we got x squared, negative 18x, and positive 81. So, any one of those methods works for you guys to use. And make sure you're getting that homework done so you're ready for class. That way if you have any other questions on ones that weren't covered, we can talk about those ones as well.